Good morning, students. Let us look into the next topic called De-Multiplexer. So, a demultiplexer is a device that takes single input and forward it to any one of the several outputs. So, I can say demultiplexer. In short, we can call it as DMUX or one-to-many. One means single input, many outputs or several outputs. So this demultiplexer, if we see the proper definition of a demultiplexer is, it is a device that takes single input and forward that input to any one of the several outputs. Now in this case, you have a single input and four outputs which is connected to four different output devices. So the input which is coming from the computer or desktop, to which device it needs to go, whether it needs to go for a laser printer or fax machine or inkjet printer or pen plotter, is decided by the demultiplexer with help of select lines. So the select lines will tell this input has to be forwarded to either D0 or D1 or D2 or D3. So which of the outputs the input has to be forwarded. This is decided by the selection lines. So let us look into the problem now. A problem definition is demultiplexer. The definition for demultiplexer is it is a device that takes single input and forward it to the one of the several outputs. This is very important. Any one of the several outputs. This is the block diagram of a demultiplexer, single input and several outputs. So output lines are indicated by N. So since it takes single input and forward to any one of the several outputs, this is done with help of what? Select lines. So now we need to decide how many select lines a demultiplexer should have. So this depends upon the number of outputs. So the formula for select lines is 2 power m is equal to n, where m is the number of select lines, n is the number of outputs. In this case, if we see this case, there are four outputs. Since we have four outputs, I can write 2 power m is equal to 4. So 2 power m is equal to 4 is nothing but 2 to the power of 2. So m is equal to 2. So that is the reason we have two select lines. So in this way, we need to decide the number of select lines. Let us start with the first demultiplexer, 1:2 demultiplexer. So if you want to design a 1:2 demultiplexer, first step is write the problem definition. Problem definition is to design 1:2 demultiplexer, which has one input and two outputs. This is the block diagram for the demultiplexer, which has one input and two outputs. Input is represented by I, output is represented by Y0 and Y1. Now I need to decide how many select lines this 1/2 demultiplexer should have. So for that, I need to apply a formula. 2 power m is equal to n. 2 power m is equal to n is number of outputs, m is number of select lines. Number of output lines is 1 and 2. So 2 power m is equal to 2. 2 power m is equal to 2 to the power of 1 is nothing but 2. So m is equal to 1. So number of select lines should be 1. That is the reason we have given one select line here. So one input, two outputs and one select line. Now let us see the third step. The third step is we need to draw the truth table. So how many select lines? S0. S0 is a select line. How many outputs? Y0 and Y1. I have given the outputs Y0 and Y1. Since only one select line, how many combinations? One select line. So two combinations, 0 and 1. That select line can be either 0 or that select line can be either 1. If it is 0, select line is 0, then we will forward I to output line Y0. If the select line is 1, we forward that input I to output line Y1. So the function of demultiplexer is to forward the input to any one of the output. So if S0 is 0, I forward I to Y0. If S0 is 1, I forward I to Y1. So that is why the truth table, if S0 is 0, I forward the input to what? Y0. So Y1 will be I is forwarded to Y0, Y1 will be 0. So I have written 0 here. If S0 is 1, I forward I to Y1, Y0 will be 0. Y0 will be 0, Y1 will be I. Now let us derive the logic expression. The output Y0 is nothing but S0. Can you see here? Y0. I need to write the expression for Y0. Y0 is nothing but S0 bar I plus S0 into 0. Can you see? S0 bar I plus S0 into 0. This term becomes 0. So Y0 is S0 bar I. Clear? So let us write the expression for Y1. Now Y1, if you see, it is S0 bar into 0, S0 bar into 0 plus S0 into I, S0 into I. Since this term is 0, Y1 is equal to S0 I. So we got expression for Y0, we got expression for Y1. Now we need to draw what? Logic circuit. So what are the inputs? S0 and I are the inputs. S0 and I are the inputs. Now what is Y1? Y1 is S0 and I. So take S0, take I, apply a AND gate, you get Y1, which is nothing but S0 I. Now what is Y0? S0 bar I. So go to S0, put a NOT gate, output of NOT gate is S0 bar, and I connected to AND gate, I get my output Y0. This is how we design a 1 by 2 demultiplexer circuit. Today we will see this. In the next video lecture, we will see how to design a 1 by 4 or 1 by 8 demultiplexer. Thank you.